Oh, I got 10 minutes to find it. That's good.
If you haven't put your data into the spreadsheet, please put your data into the spreadsheet. Actually, I'm going to disconnect from all.
It was actually just a dream. Yeah, I totally did that.
I slept right after school because I was tired, and I had a dream that I fell on a positive stuff, and then I didn't fail it.
If you haven't added your data into that spreadsheet, please add your data into the spreadsheet. I sent it to you via email. And the rest of you guys, oh, we're starting. So why don't you get your lab out, get your calculator out, get a pencil out. And we are going to calculate.
I know, like, Spanish really well, and then I graduated.
Place your right hand over your heart and begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all.
I feel like it's those voices when they teach you how to dance. It's like, place your right foot forward. Now go left foot. Right step 2, 3.
Welcome.
Right.
I don't know what type of dancing video.
This is a whatever fitness time.
Yeah.
Three,
Push-up test.
2, 1, start.
So they still test you on how much you improved?
For what?
Like in PE in my day, it was like your grade is based on how well you improve. So then you would, so then you'd purposely try to only do like 2 push-ups, like, oh, I can only do 2. And then it's like, now I'm up to 6. Yay.
There you go.
I think I don't think we graded us based on what we did.
They just said, did you do it?
Exactly.
All right.
If you did
Good.
it.
They did not.
Okay, so all of you at home, have your lab out, pencil, calculator. And like I said, this is one of the few labs we're going to walk through everything step by step by step. So the first thing we got to do is make sure that we have all the time data. So I'm going to share my screen. And come on, share screen. And let's go to so Avery, you got to put your data in. Deering, you got to put your data in. Ava, you got to put your data in. Mike will have his in a second. Yova Soccer, put your data in.
I don't have any water. Do you want to choose water?
Use the distilled water from the bottle. You know, the squeeze bottle, it's got the distilled water. So we can't go forward until we got the data from you guys. Pent, what temperature did you do? You gotta put your temperature times in here.
Yeah, I did it in 40. It updated on my screen.
Is the 5.1?
Yeah, that's your temperature, 5.1. Ava, are you there?
I don't know, I said hi, and she didn't answer me.
Nathan, we're doing a whole class set of data. That's what I said. So everybody's going to put their data in and then we're going to average it, but I need you guys to put your data in. So Deering, why aren't you putting your data in? Avery, why aren't you putting your data in? Am I muted? What the heck?
It might be.
You're not muted.
No, I'm not on mute. Ava, put your data in. Jackson, put your data in. Avery, put your data in. Okay, this is going to piss me off. Where are they?
Maybe so she
well-
doesn't know what to do.
You just got to put in your times for the experiments you did. Well, Avery's not there. That explains that. And Deering isn't there. That explains that. Deering, you're holding everybody up. We've been waiting for you to put your data in.
Doesn't happen.
All right, forget it. We're just moving on. So experiment number 1, we got 421, 106. Jackson, Jackson Pent, 421, that's really for experiment 1 at room temp?
Yeah, remember our experiments like turned brown instead
So
of
this
blue
is why I don't
and
like
took
doing
forever.
group labs. Jackson Pent, unmute yourself and tell me, is that really the right value?
Yes. Yes, that is really the value that I collected.
Yeah, it's talking, but it's just not.
Jackson, can you talk now?
Okay, yes. Can you hear me at all?
Okay, now we can hear you. Okay, so
Okay.
I wonder if the problem is maybe you can't talk when I'm sharing the screen. Let's try that again. No, you should be able to talk
Really? Okay.
through the screen.
Yeah,
Probably just using the speaker from the TV.
Okay, so is that number right there truly for room temperature 421?
yes, that is the number that I got. Remember, our experiments were the ones that were the wrong color.
That's okay. We're getting rid of that one. All right. We're getting rid of that one too. So normally you put a strike through, but I don't think I can do a strike through with this. If I do a strike through, I think it'll mess up my average. So getting rid of that one. Looking at the other data. Deering, you putting your data in yet? Or what are you doing at home? Wait, don't answer that question. All right, so we can't putz around all day waiting for people. So the average of this is going to be calculator. So the average is 73.2. Experiment 1. Experiment 2. Ava, thank you for putting that in there, but we're going to strike it.
Sorry, I'm putting in all Vegas data and she sent it. And it's all in like 4 minutes.
So .11 or 12.0. 9.5 plus 104.7 plus 11.46. Jackson Pent, sorry, I'm striking that one. Not that I don't like you, Jackson. Don't take it personally. So when you do data analysis, you can look at your data and decide, hey, something doesn't look right with it. God almighty, I hate this freaking calculator.
You want this one?
I do.
Is that a poor operations calculator? It's
the scientific calculator. That's what I'm doing.
All right. Average 40.4
For three.
for 3.
Hey, look at that.
So I'm just calculating the averages for everybody. Right. Let's see here. It's too bad we only got 2 data points for number 1, but it is what it is. So 40 degrees. 21 is room temperature. So that would be 73.2. So experiment 1. So this number up here is the room temperature one. You don't have a table for this. We will be able to fill that stuff in once we have 9 degrees. Somebody, Ava, I know you were at 9 degrees. Because you're not in this, like, who, you didn't do the lab yesterday, Ava. People who did the lab yesterday was at 5 degrees. The people who did the lab on Friday was 9 degrees. Because you did the lab on Friday, right, Ava?
That was my fault.
That's all right. But Endearing, where are you, kid?
What do you, I put my data in.
I don't see any data from you.
Oh, I'm.
You put it in the wrong.
The data in. I can. I don't know. That's weird. I don't even know what to do. Because like in my spreadsheet, I see it put in.
Yeah, there's 2 different kinetics lab spreadsheet. You should have gotten an email with the other one.
Oh.
First, mine opened up the same one that you're on, and then I had to go and open up the other one.
Well, that would explain it.
Yeah, which one's the right one? Okay. I can put my data in now.
Kaya, is that's in minutes? So the 1 minute and 51 seconds would be 131 seconds. When it turns that color. Oh yeah, 111. Okay. Not doing anything with the average ones yet. So that's 132. There should have been someone else, but sorry, Abe, I'm gonna strike that one. Something's wrong with it. So I think we're just gonna go with the 0 degrees, the 5 degrees. $32. Oh boy. You got 158, Kira? Yeah. Okay. Not gonna do 9. What did you get for a 40-degree time, Mike? 8 seconds? Yep. 53, 73. Oh, I think I got to recalculate this one. That can't be. Sorry, Aiden, that one's getting the axe. All right, we got our data. So this is going to be the times that we're going to put in for experiments 1 through 8. I'll probably have to toggle back to this. So yeah, I know they turn brown, but it shouldn't matter that they turn brown. As long as you're getting the color change, but it looked like, yeah, that some of those didn't turn out as nicely as we'd hoped, but all right. So let me get my iPad here and we'll start putting the data then into our tables. Okay. All right. So we're going to take our average times and we're going to fill them in on this table. So if I start getting too far ahead of you guys, you're going to just have to unmute yourself or send me something in the chat and say, hey, slow down, Mr. Strauss. So let's copy I will bring up so here are our averages: 73.2, 12, 40.4, 59.2, 50.6, 35.4, 13.52, and 13.57. So that data will be the same for everybody. All right. Sorry.
No, it's okay.
All right. That's not what you want. You want zoomy doom. All right, how are we doing so far? So we all have our times written down, and now we get to do a lot of fun calculations. All right. So we need to calculate the initial concentrations of each of these things. So I'm going to walk through. Oh, this is going to be a nightmare. I'll walk through how to calculate it, and then I'm going to break you guys, and I'm going to give you each of you 2 experiments to do, and then we'll share out the data. Okay. So in your lab, wherever you're writing this, we should be able to insert a new page. I'm just going to do it in this spot right here. So let's just start with the iodine. So when I look at the iodine, and I scroll back up here, that was my concentration. Okay, I had a 0.010 molar solution of iodine. Now you might think, Aiden, oh, that's my concentration. Well, not exactly, because we added all this other stuff that diluted it. Okay. So if I'm not mistaken, these all add up to the same number, as they should. So if I go horizontally, 2 plus 4 plus 2 plus 1 plus 1 plus 2 should equal 12. And it should equal the same amount for all of them, right? 2, 4, 8, 9, 10, 12. Okay. So we're diluting it down to 12 milliliters. So I've got 2 mils. I got 2 mils of the potassium iodide. So the formula we're going to use is volume 1 times molarity 1 is equal to volume 2 molarity 2. So volume 1 times molarity 1 is equal to volume 2 times molarity 2. This is a quick way to find out what the new molarity is. As long as your volumes are consistent, you're okay. I'm kind of breaking my own rules here. I hate doing this, but molarity is in moles per liter, right? But our volumes in milliliters. As long as you keep your volumes consistent, we don't have to worry about that. So we have 2 milliliters times 0.0100 molar is equal to our new volume, which is 12 milliliters. And what's the new molarity? Right? Oh, geez, sorry, not a plus sign, multiply. So our initial volume times our initial molarity is equal to our new volume and our new molarity. So when I do that, I get 0.00167 molar. So that's my new molarity. So then what I would do is then I take this number, and this is potassium iodide. That's the new molarity that I would put right here. Now it's to the 1, 2, 3 negative third. All right. So yep, let's do that. And 00167. All right. So I'm going to break you guys. I'm going to give you each person an experiment to do, okay, to calculate it out, and then we'll compare. Obviously, when you're doing the bromate, use the bromate. And when you're doing the hydrogen, you're using the HCl, okay? So Kiera, why don't you do experiment 1? And as far as grading goes, I just want one example calculation, okay? So you don't have to show the calculations for all 8 experiments. One example calculation is good.
Can we just write the calculations that we're doing?
Yep, yep. So Kiera, why don't you do experiment 1, Tyler, experiment 2, Luis, experiment 3, Mike, you got experiment 4, Kaya, experiment 5, Ethan, experiment 6, Aiden, experiment 8. Okay. And then at home, Ari, you've got experiment 7, Calder, experiment 1, Ava, experiment 2, Ian, experiment 3, Adriana, experiment 4, Jackson, experiment 5, Jackson Deering, experiment 5, Jackson Pent, experiment 6, Lucia, experiment 8. Did you get that, Lucia? Experiment 8. And Nathan Jerns, experiment 7. And Zoe, experiment number 1. Okay. So go ahead and calculate the concentrations for all 3 of your experiments, and then we'll share data in about 5 minutes. Okay. The molarity is from up there. So you got 0.040. The initial molarity, so the question is, where do you find the initial molarity? The initial molarity Deering is right here from table 1. So the initial molarity is 0.10 molar for the potassium iodide, 0.1 molar for the HCl, and 0.040 molar for the potassium bromate. Okay, so there's those 3 are the initial molarities, and then you get your initial volume from the data table. Okay. Good question.
The 8 plus comes from the HCl, right?
Right. So whatever the concentration of hydrochloric acid is, that's the initial concentration of the hydrochloric.
Yeah.
Yeah, it is.
I've been just doing that the whole time.
I did a lot of work.
Yeah, me too. This class definitely goes by. That's the fastest class. Yeah. I think calculus.
You got all three of yours, Kara?
Yeah. Yeah, I think it's that.
What'd you get for the bromate?
0.006, and then the 6 repeats.
And the H plus?
Point 016, just the 6 repeats.
Wait, 0.016? Oh yeah, that would make sense. It's 10 times stronger.
Right, yeah.
Got yours, Kaya? What experiment did you have? Okay. Three point 3.9 times 10 to the negative fourth. Okay.
How many zeros is that on the first one? 3?
I finished too.
You know, I wouldn't write this data down yet because I'm gonna write it down. Well, I suppose you can write it down. If it's wrong, we'll just erase it. That's what pencils are for, right? What'd you get, Tyler, for number 2, experiment 2?
0.0034, 0.0067.
2 zeros?
No, 3.0.
Who had experiment 3? What'd you get, Luis? 0.005. 0.00? Yeah, but we need 3 sig figs. 0.005. What came after the 5? Go back and recalculate it, okay? Mike, we'll come to you.
I got 0.00167.
Okay.
And I got 0.013.
0.013.
0.0167.
0.0167. You should all be 3 sig figs because when we did our measurements, we were looking at 3 sig figs, like 2 milliliters, okay? And furthermore, our molarities were all to 3 sig figs, like we had 0.00400 molar. So all of these answers should have 3 sig figs. Someone's in the Zoom, got kicked out. Experiment 6. Okay, Ethan.
For iodine, 0.00167. 0.00667. 0.0333.
Okay.
Just 1 0.
Oh, and the last one, just 1 0. 0.0333. Okay. Let's see here. Experiment 8 was you, Aiden, right? Are you ready?
For the first one, I got
0.00250.
and then
0.0250. Okay. Luis, are you ready with experiment 3 now? So it's 0.00500. Right? Is that because we need 3 significant figures? So if your calculator tells you this, then you have to add on your 2 zeros to have 3 sig figs. Okay. I just wanted to make sure you weren't doing like this and you're like, oh, I'm just going to erase the last 2 digits. Okay. What comes next? Actually, these should all be 667. Because there should be 3 sig figs. And your last one? 0. Tyler, you had experiment 2. Did I do this one right? Did I put that in correct?
Yeah.
Okay.
And then the other one.
Okay. I'm trying to remember who had. Okay. Aiden, can you double check your, and this is why we're doing 2 people. Can you check your calculations for the bromate and the H plus?
I got the same thing. It's just the values are switched on the table. So I like got 0.01 for the BR.
So
Like
you're
they're
saying,
just in the wrong column. But I got the same values.
okay. Wait, did I write that correctly? Is it 0.0250? Okay. Who had experiment 7 at home?
I did, Strauss.
Okay, what did you get?
For the first one, I got 0.00167.
Okay,
Second one is 0.00667.
okay,
The third one is 0.05000.
0500. Okay, so let's just kind of run through this here. Ari, do they have the right concentrations? Calder, do they have got the right concentrations?
For 1?
I don't know. Which one did I have you do?
1, and yeah, I got the same concentrations.
Okay. Ava, how about for yours? Are the concentrations correct?
Yeah.
Ian, how about yours?
Yep.
Adriana, how about yours?
They look good.
Okay. Let's see. Did I get everybody? Deering,
I got 0.02 for the bromate.
what experiment did you have?
5.
You said you got 0.02 for the bromate.
Yeah. So it's 6 milliliters of the bromate at
You want to
0.04
double check your
molar.
calculation, Kaya? Pent, how about yours?
I had 6 and they're all the same.
Okay, Lucia, we already checked in with you. Nathan, we checked in with you. Zoe? All right, so we're just checking on one of them. In fact, I can probably do that myself too. So the bromate.
And then for experiment 5, is it 0.0790?
I got 0.02 as well.
Oh, and then also I didn't even notice this, but the other two are wrong too. The 0.00167 and then 0.0167.
That is my recollection as well from doing this lab. My guess, Kai, is you probably didn't follow. It's easy not to follow across the line. You know, you might be thinking you're on that right experiment and you might have combined. All right. So now we got the concentrations. Now we're going to calculate the rate. Okay. So I'm going to erase this. And we're going to go back in time down to this. So the rate of the reaction is going to be equal to our change in concentration of the thiosulfate divided by 6 divided by time. Okay. So just to kind of just reiterate why we're doing that. Let me write the equation down. So this is our equation. So the rate of the reaction can be equal to the change in concentration of iodine over time divided by 6, or it could be the change in concentration of the bromate divided by time, or it could be the change in concentration of the H plus. So that's how we could find the rate. What's the problem with using those 3 substances? They're all clear. So how can you tell that their concentration is changing? Okay, so you can't. So that's why we had this secondary reaction, and that is the iodine reacts with the thiosulfate. You don't need to write these reactions down because they're all there on your page. So the secondary reaction, we know the concentration of the thiosulfate. I mean, we know this concentration, okay? And let's just calculate that concentration right now because it'll be the same for all of us. Go back here. We're adding 1 milliliter to each of them. So every experiment has got the same concentration of the thiosulfate. I will just show you the calculation. 1 mil times the molarity divided by the new molarity. All right, so the molarity is 0.33 times 10 to the negative fifth molar of the thiosulfate. That's the molarity. I can write that down here. Okay. So that's my concentration. So the iodine that's produced here will go there and react with the thiosulfate. What happens when all the thiosulfate is used up? Sure. Right. So Kira responded that once all the thiosulfate is used up, then the iodine reacts with starch, and then it turns blue. Okay. So we have a lot going on here. So if I know that my concentration of thiosulfate is equal to the change in concentration of iodine, so iodine divided by delta T is equal to this. What I did was I substituted, oh, I can continue this over here. Right? I substitute this in for this. So by the change in concentration of iodine is equal to this, I substitute that in for there, and that's how I get my rate equaling the change in thiosulfate, and then I still have that 3 out front right there. So 3 times 2 is 6. So I know that was a long explanation, but I think it's important to understand how this reaction is actually happening. So my change in concentration has to be this, because it's all getting used up. But I start with that much, all of it gets used up, so I know the final concentration is 0. So my change in concentration will be that much. I'm going to divide it by 6, and then I'm going to divide it by my time. So for experiment 1, my rate would be 8.33 times 10 to the negative fifth molar divided by 6. And then what's my change in time for experiment 1? I would just go back. There's my time, right? 73.2. So I'm going to put that in. And then I can calculate the rate. So what I'd like you to do is go ahead and calculate the rate for the same experiment you did before, and then we'll double check to make sure everybody's right. So go ahead and calculate the rate for the experiment you did before, and then we'll share in just a second.
that 8.23 number like for every?
Yes, because when you look, the question was the 8.33 the same for everybody? And the answer is yes, because you can see here, the volume isn't changing. So we've got the same volume for every experiment, so it's going to be diluted by the same amount for every experiment. Let's see here. Luis, what'd you get for experiment 3? Okay. Tyler, did you get experiment 2?
Yeah, but it's all right. All right, let's say. So it's 1.16 times
6. All right. Just kidding. -6. Who had experiment 4? Was that you, Kaya? You had 5?
I'm not
Okay, that's all right. What do you have, Kaya? 7.02. Ethan, what'd you get?
3.9.
Aiden, what'd you get? Okay. Jurens, what'd you get for experiment 7?
1.02 times 10 to the -6th.
All right. You have experiment. Oh, Mike's still waiting. Who had experiment 4 at home?
I still haven't gotten the answer for it.
Okay.
I got 2.407 times 10 to the -7.
So looking at the data table here, and you should always be a little suspect when a number looks different. So I'm just going to recalculate that number just to make sure. This is what I got. Which makes me think, why don't I show you how to use your calculator? Because I'm sure you understand the math, Kaya, but I'm not so sure that you're using your calculator right. My guess is you're doing the order of operations wrong. You got to understand how a calculator is programmed. A calculator, you would type okay. If you type this into your calculator, A divided by B times C, your calculator says, oh, I'm going to take A, I'm going to divide it by C, B, and then I'm going to multiply it by C. That's what the calculator just did. Okay. So that's why when you type into your calculator, you have to go A divided by B divided by C, because then it says, okay, I'm going to take A, I'm going to divide it by B, and then I'm going to divide it by C again. All right. You're cruising. Not really. That's okay. I knew it was going to be a slow day today. That's why I said if you're falling behind in any of your classes, the next few days are the days to catch up because there's going to be no homework.
2.74
Okay.
times 10 to the -7.
So I don't know if you remember back in chapter 12, they would just give you this data. Okay. We actually compiled it, and it's a good, good lab to say, okay, how do you actually get this data? Now we have to pick experiments because we want to find our rate law. And our rate law would be this I to the N, bromate to the M, and H plus to the P. So we have to find K, N, M, and P. So I suppose this will be, I'll show you one example, and then maybe we should just all pick the same ones to figure out. So we want everything to cancel except for one thing. So when I look at experiment 2 and 3, actually I could do 1 and 2. Might as well just do 1 and 2. Actually, I'm going to do 2 and 3 because we had more data points for 2 and 3. We could pick experiments 1 and 2, or we could pick experiments 2 or 3. I'm going to pick 2 and 3. So I'm going to do experiment 2 over experiment 3. And I'm just going to double check the rate for experiment 2 here. If that's right. So I got 1.16 times 10 to the negative 6th over 3.44 times 10 to the negative 7th is equal to 0.0034 to the n over 0.005 to the n. And then I got 0.00667 to the m, 0.00667. And you only have to show one example calculation of this. And considering I'm doing it, so hopefully you remember how to do this. Otherwise, it's a good review. You pick 2 experiments so that everything cancels except for one thing. So I picked experiment 2 or experiment 3 because that cancels, that cancels. Oh, I forgot to write my K's in there. The K's cancel. And so then I'm left with this. 1.16 times 10 to the negative 6th over 3.44 times 10 to the negative 7th is equal to 0.0034 divided by 0.00500. Because they're to the same exponent, I can combine them and just do that. So then I'm going to oh yeah, it should be, but it's too late now. Well, this is what I get when I do that division and I do the other division. Okay, don't leave. This will only take a second here. There's no homework tonight. So 3.36 is equal to 0.6 n. So how do you get rid of n? Take the natural log. And you thought you'd never use natural logs in your life. You can, yes, you can use log base 10, you'll get the same answer. What? You got a negative answer? Can't just erase the negative sign. All right, so I ended up with double checking a -3. So remember I said those numbers can be any real value, but since it's negative, we're just going to say n is 0.
Okay.
All right. So if you get a negative value, we're going to say n is 0. So that's why they designed the problems to work out nicely in the book, because in reality, it doesn't work out so nicely. Especially because how are we, even though we were getting a color change, how are we determining when to stop the stopwatch? Our eyeballs, which are not very accurate. So tomorrow, I know, Ava, you're going to be sad, but we're going to wait till tomorrow to find n and p, okay? Good work today. Hang in there. Yes, thank you so much, Tyler. I would have lost the last 2